So good morning everyone, welcome back. So we'll continue with the chapter number 4 that we were discussing last time, discrete random variables. If you recall, we were talking about binomial distribution. Can you think of some examples? Any example of where we can apply binomial distribution? I gave some ideas last time. So in what situations can you apply or can you use binomial distribution? Yeah.
When there's one of two possible outcomes, so say there's a success or failure.
So two possible outcomes, it could be success or failure. So somebody goes for an interview, they may be successful, they may not be successful. Yeah.
There's a fixed number of trials.
So there's a fixed number of trials. So n, because if you recall, we used two numbers, n and p. So n is like how many trials or experiments we have. So fixed number of trials. Anything else? Yeah. Trials are independent. So the probability basically remains same from first trial to other trial. It doesn't matter like what was the previous trial. If you toss coins, even if you get like 15 heads in a row, next time it can still be head because there's a 50% chance. So it doesn't change. Probability doesn't change because they are independent. So one thing doesn't impact the other. Okay, so one example that we used last time, we had 3 coins, n was 3. And suppose we have a situation where we are defining random variable as number of heads. So we know that when we toss a coin, probability of getting head or tail is same. So we can say probability is half or 0.5. And for this one, we created a small table called probability distribution table. We can find those probabilities very easily using binomial distribution. There we listed everything, but we know that for such a small problem, it is possible, but it may not be feasible if your n is large, like 50 or 500. So that could become challenging. So how do I find out probability using binomial distribution? So for that, I'm going to use Posit cloud and show you like how you can easily do that. I will use the same project that I started first time, what I showed you. This is chapter number 2. So we did few things and I showed you how to do that. And if you go to files in the 4th window, you can see chapter 2. Now another thing is when we have many projects open, how do we identify which one is ours? So I'm going to label this as business statistics. So the next time I don't have to search. How to open a new file? We go to file and then new file, and we are only doing the first one. And while there, we can also go back to file and say save as and give it a name, chapter 4, and hit save, and then you'll see this file is now created. So whatever we do will be stored there automatically. Now that we have created this file, we don't have to even worry about saving it. It saves in the cloud automatically every now and then. Yeah. Oh, light, okay. We had few things earlier. I'm going to just clean it up. So there's a broom there. If you say yes, so that will be gone. And then in this window also, I want to just clean it up. And once I'm here, we can start with a clean slate. I'll also close down chapter 2 because anyway we have it here. The example that I showed you, I can call that example 1 today. N is equal to 3. We are tossing 3 coins and the probability of getting head is 0.5. So for binomial distribution, these 2 numbers are always needed. Without that, we cannot do any calculation. So how do I find out what is the probability of getting exactly 2 heads? that we calculated manually earlier. Now I want to use a binomial distribution. So for that, let me write down what I'm trying to do. What is the probability that x is equal to 2? So this is what I'm trying to calculate. So far, with the hash symbol, I'm just writing a comment. It's not an instruction for R to do any calculation. This is only for information. So in the next line, I'm going to use a function called d for distribution and bin. As I start typing, something will come up. If there is any function already available, it will show up. So it is always better to just select that one so that we don't make any error typing. So when you select that, it needs the information that we have provided. So we are interested in probability of x equals 2. So put 2 there. And then n, which is 3. And then p, which is 0.5. So it only needs those three things. Now, anytime you are using such a function for any calculation and you are not sure, if you have a question mark in your mind, like how do I know what exactly to input? So whenever you have that kind of question for any function, you can go to this console and put a question mark and say dbinom, and your fourth window will become a help window and give you all the details. What are each items in that formula? It gives all the definitions, a lot of examples. But if you run this, now how to run this? You simply click run. The answer is 0.375. So if you recall, I think what we got was 3 divided by 8. You can check whether this is the same number, 3 divided by 8. So that same number, 0.375. What we calculated, taking a lot of time, writing down all possible 8 combinations, counting how many ways you can get 2 out of 3, and then doing 3 by 8. Here you get your answers straight away. What you could also do here is, we know that n is 3. So maximum number of trials is 3. So what values can x take? Like how many heads you get. So what are the possible values for x? If x is number of heads you get when you toss 3 coins. So x can be 0, like no heads. So what are the possible values? Yeah. 0, 1, 2, 3. It cannot take a value of 4 or 5 because you tossed only 3 coins, so maximum is 3. So suppose, I just want to show you while we are here. Suppose in x, I input with the arrow 0, 2, 3. Now it will contain values like 0, 1, 2, 3. So when I run that, you can see x contains values 0, 1, 2, 3. So those are all values for x. Similarly, let me calculate a probability, and within that store using dbinom, distribution binomial, and I'm giving an input of x now. I'm not giving one number, but I'm giving everything 0, 1, 2, 3. So x and n is 3 and p is 0.5. So you run that. Basically probability will calculate everything for 0 and then 1 for 2 for 3 and store it there. And then I will like to plot these. So y should go on y-axis, and then this curly sign tilde below your escape button, and then x I want on x. Oh, sorry, there's no y, right? It's called probability. So probability will go on y-axis versus x. So when you run that, you get this plot, that what is the probability that x will be 0? This one, very small, 1 by 8. What is the probability that it will be exactly equal to 1 head? That was like 3 by 8, so 0.375. What is the probability? It will be 2. So it gives probabilities for each one. Getting a probability exactly at a value is one thing, but sometimes we are interested in what is the probability that x will be less than equal to something. X is less than and equal to, let's say, 2. Probability of x equals 0 plus probability of x equals 1 plus probability of x equals 2. You can calculate this individually also and then add them, like add this to this, add this to this, and get the total. But there is another function that you can use, and it is called P for probability and then binom. So now you are calculating cumulative probability in a way. What we supply 2 because we want 2 and less. And then you supply n is 3, and then p, 0.5. So when you run that, you get 0.875. But this function that we are using, by default, it will give you a calculation for the lower tail, like values less than equal to something. But if you want a probability of x being greater than something, say greater than 1. So now we are looking at upper tail, not the lower tail. So we'll have to modify this slightly. Type P, binom, and then you type 1, because we are interested in greater than 1. N is 3, P is 0.5. And then put a comma and say lower. As you type, it will automatically come. So select lower dot tail. And you can see this is from P binomial function. So select that. Basically, it is asking a question, is it a lower tail? So when you are doing something on the higher side, it is an upper tail. It's not a lower tail. So we have to say this is false, F. So it will know that it is not a lower tail, it is upper tail. That's the only extra thing we do. And we run, and that probability is 0.5. So what is this probability? What is the chance that when you toss 3 coins, you get more than one head? It could be 2, it could be 3. You can get all those probabilities from here also, like what is the probability of being more than 1? So you are adding this plus this, which is 0.5. We can do that here, but what if you have n equals 50? So then you have so many points and then you have to keep on adding. So it is much better to use this kind of function and get a quick answer. So these 3 are key functions that we can use all the time and calculate any value of interest for binomial distribution. So we had 3 situations. So one is, what is the probability that a random variable x is equal to small x, like some specific value, exact value that we are interested in. You can use a function in R, D for distribution, binom, and then you put this small x value, and then input n and p, and that will give you probability of x equals x. Similarly, how do I calculate probability that capital X is less than equal to something? A very specific number, small x. Instead of D binomial, I suggested P binomial. So P for probability. So P, binom, and then you put x, n, and p. Similar format, and it knows that now we are calculating less than equal to something, and by default it is lower tail. Third and last situation is x greater than. So what if we are interested in the upper tail? So remember here there's no equal sign, that means that value is not included. So it is more than x. So that is going to be p, and then you say same thing, x, n, and p, but also lower dot tail equals false, uppercase F. So we can type the entire false or just the first letter, that is okay. So this is what you will do to speed up things. So these are all R-related functions. So let's look at one example. Try it 4.5. 65% of people pass state driver's exam on first try. When reading a problem here, actually we know that we are working on binomial distribution. But once we complete the chapter, then we would have covered like more than one distribution. How do we figure out whether we are working with binomial or Poisson or hypergeometric? So that's where, like, when you read, it will tell you, like in this case, it is giving me P. P is 0.65, and then it gives me N, a group of 50 individuals. So N is 50. So when N and P is given, that means we are talking about binomial, because those are the two things you need. So 50 people who have taken this exam, randomly selected, give two reasons why this is a binomial problem. There could be many, but what could be two reasons why this is a binomial situation?
Pass or fail.
So a driver, somebody either fails the test or passes the test. I'm sure all of you passed first time, right? So success rate is usually high, 65%. What could be other reason why it is binomial? One, yeah.
Every trial is independent.
Trial is independent. So theoretically, trial is independent, but when things involve like human beings, sometimes we do get influenced. When we say independent, sometimes like we have to see very carefully, because if it is like things may be independent, no problem. But when it comes to people, sometimes who is next to you or what happens before you could have some impact. But let's assume that these are all independent, like one person's test doesn't affect other person. And also, like, one can say the probability remains same, whether it is person 1, 2, 3, and so on. So for everybody, the probability of passing is 65%. Okay, second one. During NBA season, a player from LA Clippers had the highest field goal completion rate in the league. So this player scored 61.5% of shots attempted, which is quite high, 61.3%. So immediately you see P is given. Suppose you choose a random sample of 80 shots made by this player in the season, and it's already defining the random variable for you, the number of shots that scored points. So that is the variable of interest. What is the probability distribution of X? It is just asking what is the probability distribution of X, because in second problem nowhere it talks about binomial, so it wants us to just figure out what kind of distribution it is. For the first one we wrote N was 50 and P was 0.65, and we gave some reasons. Now for second one, N is 80. So somebody takes a sample of 80 shots, and the probability that the player scored was 61.3%. So A is asking what is the probability distribution of X, where X is number of shots made by the player. Typically we write like this: X follows binomial distribution, so we can say B, with N equal 80 and P equal 0.613. So the question was, what is the probability distribution? It is binomial with N this and P that. Part B was asking about mean and standard deviation. What is the average and what is the standard deviation? Mean for binomial distribution is given by N times P. So N is 80, P is 0.613, And if you calculate that, you should get 49.04. Number of shots that scored points. So on an average, 49 shots scored points out of 80. So out of a sample of 80 shots, 49 times this player was successful. And what is the standard deviation? For binomial distribution, it is square root of n times p times 1 minus p. So if you plug in the values, you should get 4.35. C is find the probability that this player scored with 60 of these shots. Exactly 60 means x equals 60. So we are trying to find out probability of x equals 60. We'll use the first type, D for distribution, and then binom. You put that 60 that we are interested in, and then n, and then p. So that should give you 0.0036. So D, probability that the player scored with more than 50. X is more than 50, so it's a cumulative calculation, not exactly. So it's not exactly at a single point. So it will be P binom, then 50, 80, 0.613, but you have to add. So this is this third situation, x more than small x, that function that we are interested in, upper tail. Otherwise it will calculate default. Default is less than equal to. But we are not interested in less than, we are interested in greater than. So lower tail, lower dot tail equals false. So that should be your R function. Try it, 4.5, and D. So that gives you 0.371. 37% chance that more than 50 shots will make it. So that player is able to make it with more than 50 shots out of 80. So while we are here, we can try this kind of plot. So what values can x take in this example? 0, 1, up to how much? 80. Because if a player is taking 80 shots, so what is maximum? He can score all 80. He cannot score like 81 or 82. So maximum possible is 80. And the worst case scenario is like none of the shots go, so 0. So theoretically 0 to 80. So x can be 0 to 80. Our probability, so let me store in P for probability. Distribution binomial, because if we want individual values, and we supply this x, and then 80, and then 0.613. So we'll get all the probabilities stored in P, and then we can plot P versus x. So this is how individual probabilities look. This player taking 80 shots, what is the probability that this player will not make any? Almost 0. Not make even exactly 20 is almost 0. And the highest comes somewhere here, close to 50. This is a good example where you have like 80 different probabilities, and if you are calculating x is less than something or x is more than something, it is much easier to do that calculation using the functions. So this is problem number 66. Suppose 85% of graduating students attend their graduation. A group of 22 students is randomly chosen. In words, define the random variable x. So what will be random variable x here? Number of students who attend graduation. List the values that x may take. So what values can x take? Obviously it starts with 0, goes to 1, and what is maximum possible? 22, because out of 22 students, maximum is 22. Give the distribution of x. We defined random variable as number of students. Actually, before that, I always like to write what is n and p for binomial who attend graduation. X can take values from 0, 1, 2, up to maximum 22 is possible because that's your sample size. We cannot go beyond that. X follows binomial distribution with n 22 and p 0.85. D was expected value, so expected is same as mean is n times p. So 22 times 0.85. If you calculate, you should get 18.7. Now that is a number that we get. So typically, because we are talking about number of people, so we round up. So if it is 18.7, we would say 19 students are expected to attend out of 22. What is the probability of exactly 17 or 18 attending? So that is probability of x equals 17 plus x equals 18. Distribution binomial, you put 17, you put n, probability, and then add distribution binomial, 18, 22, 85. So you plug in and you should get 0.325. So this is your R function. So f is based on numerical values. Would you be surprised if all 22 attend graduation? Justify your answer numerically. So we did some calculation, but if everybody shows up, will it be a surprise? Which means, is that probability very low? Then only there is a surprise, like something rare that will happen. So first we figure out what is the probability and check whether it is low or not. And then we can say whether we'll be surprised or not. So F, you calculate probability that X is exactly 22. And that comes out to be 0.028. So based on binomial distribution, the probability seems to be very less, 2.8, less than 3% chance of everybody showing up out of those 22. So this will be unusual. There's 97% chance of this not happening, only 3% chance of something happening. Obviously, you'll be surprised. There's a much smaller chance